Okay, I'm going to go through some of the homework questions on Making Practice Fun 39. I'm not going to go through all of them. I'm just going to do a handful of them to get you started. So the first group hopefully went pretty well. We just need to rewrite them with rational exponents. So like, for example, or without rational exponents. So for example, like number 3, I just need to write that as the 5th root of a to the 3rd, b to the 3rd, because a 1/5 power is like a 5th root. Number 14, it says write with rational exponents. So let's take, or actually let's do 13. So 13, I've got 4a squared b to the 5th. And that's the 5th root. So it's going to be a 1, I'm sorry, the 8th root. So it's going to be a 1/8 power. And then all to the 7th. When I raise a power to another power, I multiply. So I'm going to keep 2a squared b to the 5th. And then I'm just going to multiply 1/8 times 7, and I get 7/8. Another question that's asked about a lot is number 22. Let's take a look at that one. Number 22, the directions say simplify as much as possible by first converting to exponential form, then write the answer using radical notation if appropriate. So I see I have the 8th root of a to the 6th. So I'm going to make that a to the 6th to the 1/8 power. Power to a power we multiply, so that gives me a to the 6 over 8. Now I can reduce this fraction 6 over 8. It reduces to 3/4. After I reduce the fraction, then write the answer using radical notation if appropriate. It is appropriate because I have a denominator here of 4. So this becomes the 4th root of a to the 3rd. And that's my final answer. The next one let's look at number, how about 24? That's a good one. That one looks a little scary. A lot going on there. All right, so first thing I'm going to do with number 24 is I've got a to the 25th, b to the 30th, all over 32. Now I notice I'm about to take the 5th root. So in the numerator, yeah, I'm going to write that to the 1/5 power, but I'm going to pause here because 32 is a perfect 5th root. I can take the 5th root of 32 because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. The 5th root of 32 is just 2. So now I'm going to go back to my numerator. Power to a power we multiply. So I'm going to have a to the 25 over 5, that's 25 over 1, b to the 30 over 5, and we've already evaluated the denominator is just 2. This problem is great. 25 divided by 5, we're left with a to the 5th, and then 30 divided by 5, b to the 6th, all over 2. Let's take a look at number 27. Number 27 is, I got the 32 again, but this time it's not a perfect 10th root, which is a bummer. But I do remember that 32 from number 24, I can write 32 as 2 to the 5th. And I'm going to employ that strategy when I work on number 27. So number 27, I'm going to have in parentheses, instead of 32 here, I'm going to write 2 to the 5th. And then I'm going to have x to the 5th, y to the 5th. And now I'm going to go to the 1/10th power. And this is going to be great because I noticed that everything has a 5. Everything has a 5th power. And when I multiply 5 times 1/10, I'm going to get all of these values, 2 to the 5/10, x to the 5/10, y to the 5/10. All of these fractions reduce to 1/2. So if this is really 2 to the 1/2, x to the 1/2, y to the 1/2, 1/2 power is like a square root. Okay, again, because it's like 2 to the 1/2, x to the 1/2, y to the 1/2, it can become the square root of 2xy. I'm going to do one more problem. I'm going to do number No, actually, you know what? I'm gonna do number 28 and then I'm gonna do 33. So let's do 28 and then we'll do 33 because those are pretty different. 28 says write as a single radical expression. So the square root of x, I can't, and the cube root of 2x, I can't like multiply those together. So what I'm gonna do is I'm gonna make it x to the 1/2, y, and then 2x to the 1/3. And what I'm gonna do, a single radical expression means they have to have common denominators. So I'm gonna think to myself, all right, 1/2, 1/3, the common denominator is 6. So I'm gonna make this, and so now I've got x to the 3/6, 2x to the 2/6. Okay, so remember, the goal is not to like simplify this, but is to write it as a single radical expression. Now that everything has a denominator of 6, I can write this as the 6th root. And then what's left here? X to the 3rd. Now here, when I put the 6th root, denominator comes here, but I'm still left with the squared. I can square 2. So times 2 squared is 4. And then x squared is just x squared. So my final answer for number 28, if I multiply this together, I'm going to get the 6th root of 4x to the 5th. Let's do 32. Okay, I'm going to employ a similar strategy as I did with 28. Remember, 28, my strategy was after I created rational exponents, I found common denominators. 33, I already have rational exponents. There's no radicals there to worry about. But I have a to the 1/2, b to the 3/4 over c to the 1/4. And then that d has a negative exponent. I don't know what it's doing in the denominator with a negative exponent. So the first thing I'm going to do is switch it to the numerator and make its exponent positive. So I examine my fractions. I have 1/2, 3/4, 1/8, and 4. And I see they have a common, I can create a common denominator of 8. So I'm going to do that. So this is going to be 2 over 2. This needs a 3 over 3, a 4 over 4. It's not a great color. 4 over 4, and this needs 2 over 2. So now I have a to the 4/8, b to the 6/8, d to the 1/8, all over c to the 2/8. The denominator here is 8. So remember, the goal is not to simplify this. It's just to write it as a single radical. So if I write this as the 8th root of a to the 4th, b to the 6th, d, I've accomplished the goal. Hopefully this video was helpful, and you're able to do the rest of the math problems on this homework yourself.